Hi, my name is dr. Ahmath. Welcome back to the course of Probability and Statistics. In this lecture, we're going to continue our discussions about the combinatorial analysis, and we're going to solve a couple of problems in order to understand which formulas we need to use in which situations. So let's start the problems. So find the number of the possible 10-character passwords under the following restrictions. So we just need to note that there are 26 letters in the alphabet. So what we need to do is we just need to create the password which contains 10 digits. So it means that we need to create 10 boxes. So on 10 boxes. So it is given that in the first one, say all characters must be lowercase letters. It means that there are 26 lowercase letters, right? So A, B, C, D, E, and so on. So since this is the password, you can use the letters again and again. So there are possibilities to repeat one letter twice or even 3 times. So what we need to do is we just need to find out how many different passwords it is possible to create. So in order to do this, we are just going to count the number of the characters which are possible to put in the first place. So there are 26 letters. We can use any of them in the first place. So once we use one of them, for example, you decided to use the A, is it possible to use this again in the second place? Yes. So in the passwords, it is possible to repeat the characters, right? It means that it is possible to put here again 26, any of the 26 letters, here 26, and so on. So actually, it is possible to put 26 letters to any position. So we are just going to multiply those numbers according to the generalized rule of counting. So it's going to be 26 in the power of 10. So let's consider another example. So all characters must be lowercase letters and distinct. So it is given that all of the letters are going to be now different from each other. So if you use one of the letters once, you can't use this anymore. So there are 10 boxes, let's say. So in the first place, you can put 26 letters. So any of the 26. If you decide to use one of them, for example, A, you cannot use this anymore in the second place. Or if you have decided to use the B in the first place, you can't use this in the second place. So there are 25 possible cases in the second place, so you can use only 25 letters in the second, 24 in the third, and so on. And at the end, it's going to be 17 at the last. So then we just need to multiply this. It is going to be the multiplication of 17, 18, 19 until 26. Or you can also write this down as a 26 factorials divided to the 16 factorials, right? It's going to be 17 times 18 times 19 and so on until 26. So there are going to be 10 numbers here. So let's go to the next problem. So the words can contain only 2 uppercase letters, either A, either B. So in this case, we again need to draw the box. So let us draw the box. So we need to create again the 10 boxes. So how many options it is possible? So we have in the first place. So again, 10 character password we need to create. How many different passwords it is possible to create? So it is possible to use any of the 2 letters here, either A, either B. So there are 2 options here, 2 here, 2 here, and so on, and 2 here. So for every box we are going to have 2 possibilities. So at the end, it's going to be the multiplication of all of these 2's. It's going to be 2 to the power of 10. So we can create 2 to the power of 10 different passwords. So the word can contain only uppercase letters A and B and must contain each of these letters. So what does it mean? It means that A or B should participate in the password at least once. So I think it's going to be really difficult if you think from a perspective that you need to create a password was only 1A, was only 2A's, was 3A's, 4A's, and so on. So what I would like to do is I would like to go from a different perspective to this problem. So I would like to find out the password which contains only the letters A and only lead letters B. So there are two only possibilities, right? So A, and so on. A, it's a one possibility. And B, and so on. B, it is going to be the another possibility. Only two passwords which doesn't contain A and B at the same time, right? Which doesn't work for this. So what I have to do is I need to find out the number of the possible passwords which can be created just using these two letters. It is going to be 2 in the power of 10. We've just seen this before, right? So only 2 letters. So it's going to be 2 in the power of 10. And then we have to subtract these two cases where we have only A's and only B's. So this is going to be the number of the cases where at least one A or one B is going to participate. So we are excluding the cases where we don't have A and B both together in our passwords, right? So the solution for this case is going to be 2 in the power of 10 minus 2. So the word can contain the uppercase letters A and B and must contain equal number of each. It means that if your password have, so let me show the solution to here. So the password should contain 10 characters. In all of these problems, for example here, where here it wasn't like restricted how many A's or how many B's we need to have in a password, right? We might have only 2 A's or 3 A's, and we needed to include all of these cases. So while in the last case it is already given that we need to have 5 A's, 1, 2, 3, 4, 5, and also we need to have 5 B's, 1, 2, 3, 4, 5, right? So what we need to do is we need to just permute those letters, like just change the positions of the A's and B's and create the new passwords, right? So basically we need to find out the number of the permutations of the 10 letters, where some of them are similar. If you remember, there was a formula to find this. So if all of these 10 letters would be different, the number of the permutations would be simply 10 factorials. But since these 5 letters are similar, the permutation between each other of these A's doesn't make a new password, right? For example, if you just change these 2 A's with their positions, you don't create the new password. It's essentially going to be the same password. So according to the formula, we needed to find out the number of the similar letters. In this case, it's going to be 5 A's, and divide the 10 factorials to the 5 factorials. And again, at the same time, we have 5 the same B's. What does it mean? It means that we need to additionally divide this to the 5 factorials. So the number of the passwords which can be created just using 5 A's and 5 B's, it is going to be 10 factorials over 5 factorials times 5 factorials. Or it's going to be just a combination of C 10 5, which is, if you just write down the formula wise, it's going to be 10 factorials over 5 factorials, 5 factorials. Oh, well, it's interesting that the permutations sometimes can be used as a combinations, right? Oh, you need to think about this. So why? So we use the formula of the permutations, and sometimes it is the same as the usage of the combinations. Good. So let's go to the next problems. So find the number of the different words which can be created by rearranging the letters of the following words. So there is a word which contains 6 letters. 1, 2, 3, 4, 5, 6. So what we need to do is we just need to rearrange the letters or permute them and find the number of the words which can be created. So actually it's going to be 6 factorials simply because there are 6 different items and we just need to find the permutations of the 6 different items. So if you don't really understand why it is 6 factorials, or if you would like to understand this more deeply, why it is 6 factorials, I would just suggest you to draw the boxes. So you can just draw the boxes here. So you need to generate a word which is going to contain 6 letters, right? And on the first position, you can choose any of these letters. So either N or R, M, A, or L. So you can just put any of the 6. So 6 letters. So if you decide to use, for example, this A in the first position, you can't use this anymore, and which means that you can use only 5 options at the second position, and consequently, 4 options on a third, 3 options on a first, 2 options on a fifths, and only 1 option on a sixth. And according to the like counting rule, we just need to multiply those numbers. It's going to be 6 factorials. So the number of the letters which can be created by just permuting 6 different letters is going to be equal to the 6 factorials. So in this case, so there is a word now, again, which contains 6 letters, but some of them are similar, so that's why it's not going to be 6 factorials, right? Obviously, by just interchanging this h and h, we are not going to create a new word. So what we need to do is, if all of them would be different, it would be 6 factorials. Dividing the 6 factorials to some number, it means that we are excluding some of the cases, right? We are basically excluding the cases where you would just interchange these 2 h's or one of the 2 t's. So basically, there are 2 h's, so that's why you have to divide this to the 2 factorials. And 4 t's, it means that you have to, again, divide this to the 4 factorials. And actually, you could just solve this as a combination of 6 and 2. So again, you need to think about this, why the formula of the combination is sometimes equal to the formula of the permutations. So they are not the same always, but you need to think about this a little bit. So our next problem is the Mississippi, which is going to contain 11 letters, 11 factorials, and we have to just now count the number of the similar letters. It's going to be 4 factorial, so there are 2 p's, 2 factorials, and 4 i's. 1, 2, 3, 4. That's going to be 4 factorials. So this is the number of the words which can be generated by just replacing the words, the letters of this word, Mississippi. So here there were some examples of on the combinatorics, simple combinatorics, which might give you some insights about the difference between the combinations and the permutations. So now let's go through a little bit more different problems. A class in probability consists of 6 men and 4 women. An examination is given, and the students are ranked according to their performance. Assume that no 2 students obtain the same score. So there are 10 students, right? So how many different rankings are possible? So if there are 10 students, how many different rankings are possible? Well, so we need to think about this. So probably we can just make again the boxes. So how many boxes we have to do? So there are 10 students and we need to order them, right? So which student is going to be the first, which student is going to be the second, and so on. So that should be 10 boxes. So in the first place, you can choose any of the 10 students. So there are 10 options. In the second place, we can choose 9 students because we've chosen already one of the students there, right? So, and here it's going to be 8, 7, and so on until 1. So then we have to multiply those numbers. It's going to be 10 factorials. So basically, it is possible to create a list of students, basically arrange them by their scores, and the number of the list is going to be equal to the 10 factorials. So let's go to the next problem. If the men are ranked just among themselves and women are ranked just among themselves, how many lists are possible to create? So now what I'm going to do is I'm going to create the list of 4 or 4 boxes for 4 females and 6 boxes for 1, 2, 3, 4, 5, 6. 6 boxes for the 6 males. So that's if I would like to just replace or rank the females among themselves, how many different possibilities, how many different rankings are possible? So 4 females. So I can choose any of the 4 here, any of the 3 which are left, 2 and 1. And for the males, it's going to be like, so I can choose any of the 6 males to here, then 5 males to here, because we have already chosen one of them in the first place. 4, 3, 2, 1, 6, 5, yeah. Then we have to just multiply them. Okay, so the only difficult part of this problem is probably to understand why we have to multiply them, right? So we are going to solve a couple of more problems, and hopefully it will. You will try to understand why we have to multiply. So here we need to use this multiplication here. So for a group of 5 women and 7 men, how many different comedies consisting of 2 women and 3 men can be formed, right? Okay, so what does it mean? It means that we have got 5 women and we need to choose 2 of them, right? So if you remember the definition of the combinations, right? So the combination C and K means choosing a list, or basically the number of the list, choosing K items out of N, right? So here what we need to do is we need to choose 2 women out of 5. And is it really important, the order in the comedy, how they are sitting in the comedy? No, it doesn't matter, right? So you choose the women 1, for example, and women 2 to the comedy, and this is basically the same as choosing women 2 and women 1 to the comedy. So you've just invited these 2 women to your comedy, and it doesn't really matter in which order you're making these invitations, right? So that is why it's going to be the combination of the 5 and 2. And choosing 3 and 7, it's going to be the combination of 3 and 7. Again, so 3 males out of 7. That's again going to be the combination 3 C 3 7. And at the end, what we have to do is we just need to multiply them. So I'm going to try to explain you why we have to multiply these 2 things. So let's say you've chosen 2 females, right? So you've chosen 2 females here, women 1, women 2. So now, how many different comedies it is possible to do for the males? You need to choose 3 males out of 7, right? So it is possible to make the combination of the 3, 7. It's going to say, let's calculate this. It's going to be 7 factorials divided to the 7 minus 3 factorials. It's going to be 4 factorials divided to the 3 factorials. It's going to be, so if you divide 7 factorials to the 4 factorials, it's going to be multiplication of the 5, 6, and 7. And we have to divide this to the 3 factorials, which is simply 6. So it's going to be 35. So it is possible to make 35 comedies of the males if you just make these 3 positions. For example, you can just do this male 1, male 2, male 3, right? Or you can make this male 3, male 5, male 6, right? Or you can make this male 4, male 3, male 2. Order, please note that the order, it doesn't matter. So you are just making different, you're choosing different males out of 7. 3 out of 7. It is possible to make 35 of them. When the comedy for the females is just fixed, so you have chosen the first female and the second female, and you have 35 different options for males. So it is basically 35 different options in this case when we just fixed the females. So now, if you choose another set for the females, for example, you've decided to choose not female 1 and female 2, you've decided to choose the female 1 and female 5. So how many different comedies it is possible to create with just these 2 females? Again, 35, right? Because now we are going to have C, 7, and 3, only for this 2, right? If you decide to choose another set of females, for example, female 2 and female 3, how many different comedies are possible to create? Again, 35. So it means that for every comedy which can be created for the females, we can create 35 comedies for the males. It means that we can create C to 5 comedies for the females, and we have to multiply this to the number of the comedies can be created for the males, because for every of this comedy we have 35 different options. So this is the reason why actually we're multiplying. So these were the examples of on the combinatorial analysis. There will be a couple of quiz questions, so I would really suggest you to go through the quizzes and try to test what you have just learned over these lectures. Thank you.